So hello everyone. For now, we will learn also another type of supervised machine learning, which is also used for a classification, which is the K nearest neighbor, or for shortening KNN. Well, this algorithm is more simpler than the decision tree and logistic algorithm and support vector machines and the other supervised learning machines. Because basically we are just only attacking the fitness function, and usually the fitness function uh, is a function for Euclidean distance or Hamilton distance, etc. Well, this one we will use a built-in data set from the sklearn library. So let's call the libraries that we're going to use this one. And instead of importing data sets from your workspace, we're going to use the iris data set, which was developed by Fisher, which is known as statistician. So NumPy as an NP, and then we will import pandas as a BD, and then we will have also importing the graphical so math plot library, Python library or plot as a PLT, and then we will start calling the data set. So from sklearn dot data sets, and it has plenty of useful data set. You can like basically train your models and test them. So load iris, which is basically we have three types of different flowers, and basically based on the features we want to distinct them. Then we will call um, the splitting function between the training and testing. So from sklearn dot model selection, we want to import train, test, and split. But this time we have a shortcut for it, so we will call it TTS. Then we will have from the sklearn calling the neighbor algorithm. So neighbors. We want to import the K-Neighbor Classifier. And again, I want to add a shortcut for it, so I will call it KNN, and I want to make it capital letter. And we want to assess this algorithm. So from sklearn dot metrics import. Again, this is will be just focusing on overall performance for this one. So accuracy score instead of like looking to the false positive and true positive versus false negative and true negative. So let's load the data. So we want to import it. Import the iris data set. So we can call it iris equals load the iris. And this is works similarly to the decision tree. So we need to have X and Y splitted. So X equals iris dot data. And we want also to have Y equals iris dot target. Now we want to split it. So split to training and testing. So we will call it the same order. So X train, X test, Y train, and y test equals, so again, train, test, and split as we make the shortcut for x and y. Since this is a small data set, so test size equals, so the same split we will have 20, 80%, and then we will have the random states to generate the seed for the function 1, 2, 3. After that, we will train our model. So building the model. And so we want to basically try different neighbors. So it's better to dedicate a number for these neighbors. So let's call it 3. So this will be the number of nearest neighbors. Now let's call the model K-N classifier, or whatever you wanted. So this is equals K-N. And now we're gonna signify the number of neighbors. So n neighbors equals k, and then you wanna fit this algorithm. So K-N fits for the training data set. So x train and y train. Now we wanna have the features to be optimized on these things. Then we wanna evaluate the accuracy of this one. So evaluation for this one, starting by the prediction. So y predict equals K-N dot predict using the testing data set. So x test, and then we're gonna build the accuracy function. So accuracy equals accuracy score between the test and prediction. And then we're gonna print it out. So print the accuracy. Okay, so we have, I think, a small typo here, model selection. So the accuracy for this model was 96, and as well depends on the sensitivity of the problem. So we might be going see how much the percentage was false positive and the false negative later on. Now we want to have some visual representation for the data set before we playing around with this one. So let's make a figure from that thing. So we're gonna define the figure size. So 20 by 15. So I like these numbers. It's up to you. So if you want to change it or whatever, BLT scatter. Now it has a many features, so we will just pick the first one. So X for the whole column, the first feature, and then between the other feature here. So the whole columns for the second one, which is 1. Okay, now we want to see also how they are lookalike. So this is the category, which is will be Y. And now we want to have a heat map for that. So for this one, their depths or their I IDS and S equals 50. And now we're gonna also have the features name on them. So PLT X label will be CPAL length in centimeter. And then we will have the Y label. This will be the CPAL width, centimeter as well. And we will have the title PLT dot title. So this is for iris data set for PayPal link versus spell width. And we want to see the species like the output. So PLT dot color bar. So we will call it label it for the species that we want to classify. And we want to show it. So PLT dot show. So this is how these are looking. So you can see this is a species and versus the other one. Now let's try to change the number of neighbors and see how it will performing. So let's call it to 2. I'm assuming the accuracy will be going down. I'm not sure. Yes, it's going down. Let's try it with only one feature here. The same as this one. Let's call it with 4 neighbors and see how it performs. Okay, so it's increasing now. Let's see. We could go to optimal. So 5. Okay, so I think the optimal number should be 3. Again, that's meaning that, but even if you increase it to whatever number you want to, will be no enhancement. Okay, so let's go to the next algorithm.